All right. Hi, folks. So we started a couple of minutes late. We just saw a whole bunch of attendees pour in, and we thought we should let everyone arrive before we got going. So I'm Dave Millington. I'm the C++ product manager, and we've organized this webinar to talk about the new C++ builder and why we're excited about it and why we think that you should be too. And so we're going to cover a few things today. A whole variety of things, actually. First of all, some of the more sort of, I don't know, webinar-y bits, talking about what it is and what it means and why we've done it and that kind of thing, but also a large focus on some more concrete information, actual data. We'll start with what it is and when to use it and why we've built it and what it means for C++ Builder. So this webinar is targeted mostly if you've used C++ Builder before, although if you haven't, you're very welcome to stay around. And then we'll move on to some actual concrete things about components and packages. We've had a lot of interesting compile speeds. We have some actual data, and I want to share with you what to expect. Talking about the different tech we're using. And we've had a strong emphasis that you've probably seen in various marketing messages on moving to the new toolchain. So why is that? Why, rather than just presenting the new toolchain as we often do when we have an upgrade, why are we emphasizing upgrading now so much? And echoing the sort of fairly concrete theme where possible, I do want to handwave and say, especially the first few slides are not very concrete, but we do get far more concrete as we go on. We want to share a whole bunch of stuff that we've collected from customers who have upgraded, the conversations we've had with them and with our support team and so forth, which I've put together in the form of about 7 tips and tricks. It's actually more with some very concrete information about what people have seen and what they've experienced, and what you can do to what can you expect when upgrading, and what to do for success. Alrighty. Just to check, Ian, my GoToWebinar is saying that we're not showing anything, even though it also says that we're screen sharing. Could you tell me, please, if anyone is able to see my slides?
We can't see your slides. You need to actually share your screen.
It is telling me both that it is shared and no one is sharing. So let's try that. Folks, okay. I just gave a wonderful spiel. Hopefully you can see that now.
Yeah, now I can see it. That's good.
Right, folks, I just gave a wonderful spiel reading through this slide, which is the agenda. But as you can see, what it is, what it means, some concrete stuff, and then getting on to real tips and tricks. And this is what we're going to go through today. All right, so what is the new C++ Builder toolchain and the new C Builder approach in general that we're so excited about? Well, in general, the new toolchain, which is what we've been talking about a lot over the past year, was finished and is released and is done in the most recent version of C Builder, which is 12.2, came out about a month or month and a half ago, 6 weeks, say. We call it the Windows 64-bit modern toolchain. A toolchain is just a term for the whole set of compiler and linker and runtime library and so forth that are all the tools that you use, basically, that the IDE and compiler uses under the hood. Look, if you're not using 64-bit, stay tuned. But we are going to be talking about the 64-bit one today, but there's info that's relevant to you if you're on 32-bit. And the new compiler is for Windows 64-bit apps. So you're targeting Windows 64-bit. It is intended to replace the old Win64 toolchain. So since 2018, we have had a Win64 toolchain that you may have used based on Clang. It is intended to fully replace that. Now, the old one is still installed side by side. So when you install 12.2, you get 2 Windows 64 platforms, and you can just toggle between them. The idea there is to make it much easier to upgrade and migrate, because you can quite literally just switch between the two. However, the new one is the default. It's the default compiler for any new project. Now, in terms of a big tech info dump slide, we have covered a lot of this stuff in our What's New webinars, but I do want to mention a little. Effectively, that it's brand new and upgraded, and it's based on Clang again, but a much newer version of Clang with all of our extras. And we have a new and completely different standard library, a new C runtime, a new linker. We have reworked a whole bunch of underlying tech. It's not just an upgrade. There has been a lot of work done on particular areas. We have reworked, re-implemented. Exception handling is the one I always talk about because it was massive work. But we have really, really good exception handling now. We wrote, I was told, just over 3,000 new unit tests just for that area. In general, the approach has been to follow the platform conventions. So we use the COF object file format, for example, or PDB debug info, which is basically what everything else on Windows does. That means that it should be a lot more interoperable with other tools. And our main focus was on doing it right, and that anything that was potentially problematic before should work smoothly now. Basically, it's been about 2 years of development efforts. I ended up, from what one of our engineers told me, with about 30,000 unit tests. It's been a massive development effort, and that's why we think it's so worthwhile. We have put a lot of work into this, into making it the absolute best it can be. A big focus on performance, a really fast linker and parallel compiling. I'll talk about that later. But the main thing is that at every stage, when we had a question, what technology do we use? What approach? Should we stick with what we did before and just upgrade it? Should we, bring in something else? What would make this most useful? What would make it most compatible? What would make it easiest to upgrade to? That kind of thing. We always asked what was the right decision, and then that's what we did. And you'll notice that the result is quite a different toolchain to the previous Win64 one. It's different on the technical level in the slides that I showed before. And it's different on a quality level. And that's why we're saying and why we're messaging with this, when should you use it? Well, now is the time. And although I'm going to go over a few other things and then concrete information about it, this is the real message of the webinar that we really want to encourage. Check out this toolchain, try it out, use it, upgrade, and know that this is where our focus is, and that we believe this is the toolchain that you should use. I want to focus as well just a little more about that message about doing it right, and about all the technology that we chose. Now, we've talked about this in release webinars, and I don't want to sort of repeat the same information too much for those who have seen it before. But we made a lot of decisions about the technology that underpins the new toolchain. And the approach we've taken is that to use the new toolchain, of course, should just take all your existing code and compile, of course, because that's important. But under the hood, we wanted it to be radically better, really different and really robust and really high quality. And I mentioned things like COF and PDB format because that's what other toolchains on Windows do, and that allows us to be more interoperable. One suggestion, for example, is that if you want to profile your code, because we use the PDB debug format, a profiler that relies on debug info should be able to use and profile an application built with the new toolchain. In the past, profilers had to add special support for us. Now you should be able to use something else. Other questions, like we've had our own C runtime. So there are often layers in a C++ toolchain. So you'll have like a C runtime and then the C++ runtime, which provides you things like exception handling, C++ style exception handling, and then the standard library on top of that, which is where you get all your algorithms and collections and so forth. Now we need to provide all of that, but Windows ships with a C runtime that's built in. So we asked, well, although we have our own that we've worked on for moved forward for many years, why build a custom one when there's a standard one built into Windows? And so we use that standard inbuilt Windows one now. Focus on LDB with the PDB debug format. We want the new toolchain to have a really good debugging experience. We know that some people prefer specific toolchains because of the debugger, and we want to make sure that the new one is good from the start, and it will only get better from here. Similar things for our STL or our linker, which can handle any size application, and it's really fast. Or the compiler itself, it's a Win64 compiler, so it creates Win64 apps, but it is itself a 64-bit app. That means it has, effectively unlimited memory. Now, why is that important? Well, we fixed a whole class of bugs just by doing that, where some C++ code, when it was being compiled, chewed up so much memory that a compiler that was built as a 32-bit app ran out of memory and crashed. So, easily, just by shipping a 64-bit compiler from the get-go, wiped out a whole class of issues. Anyway, all this kind of thing really is that we have tried to build the toolchain that we thought we should build, and the toolchain that we felt you would find valuable and that you would want to use. Super high quality, has all the extras, follows conventions, it's really performant, and it has the C builder magic. Alrighty, I mentioned that we would have a split here between a kind of like more pitch style and more concrete style, and I want to get into some of the more concrete things now. Now that I've messaged, and this is a really genuine message, we really do believe this is the toolchain that you should use, and we really strongly recommend installing it, upgrading, and trying it out. Now, based on components and packages, look, we have released the new toolchain in public over stages, which again was a new approach for us. In the past, when we've done something new, it's always been fully internal, and although beta testers who've signed NDAs might be able to see something, we have just released something just when it was done. We did something very different for this toolchain, which is we released publicly over stages. And a full year ago, last November, when we released version 12.0, we had a preview, a command line only preview of the new compiler. Then 12.1, which was in about April, I think April the 4th, we shipped the new toolchain, and it was complete, and you could run your Windows applications and build them, but everything was statically linked. So you get a single large exe as the result. You wouldn't have your components and packages and so forth. And 12.2, which we released about 4 to 6 weeks ago, is when it's done. It's the other reason we're holding this webinar now, to say it's done. And the main thing that was missing, although we added other things like parallel compilation and CMake support and so forth in 12.2, the main thing that was missing for people who were interested in upgrading was support for packages. And packages are, you may be familiar with them, they're a kind of DLL that contains extra metadata. And it's really common for components like visual components to be shipped in packages. So you ship your executable and then a whole bunch of other files along with it. And that marks the toolchain being complete and done. One slight downside that we have found of releasing in public stages is that we have seen some confusion with people about what we support. And only a couple of days ago, for example, I got an email from someone saying, look, I like the new toolchain, it looks really exciting, but I can't use it without packages. And they hadn't realized that we released 12.2 with packages. And that wasn't standalone. We've seen other things like that. And again, this is another reason for this webinar. We really want to message and want to get it out there that it is complete now. It has everything. It is a full and complete replacement. Packages being the main thing, but really this slide should just say in bright red text, done, complete replacement. And that's really what we want to communicate. So yes, you can use packages created in Delphi. So if you have your components and controls or anything else, sure, just use them. Ship the package, link dynamically, link statically, whatever you need. And you can create packages as well in C++, or mix C++ and Delphi code if you want to. So we've had some customers who have written components in C++ and needed packages before they upgraded because they need those components. And they want them in a dynamic package. And you can do that now. So really trying to message that it's done. Full replacement, feature complete. The other thing is, though, that we add a lot of documentation on packages. Now, packages have been perhaps a bit mysterious, I think, for some people. For a couple of customers who I've corresponded with for years over the nuances and how things work. Now, when we did the new upgrade, I've mentioned a few times, some of it is not just upgrading or like porting code forward. Some of it is when you re-implement something, doing it better the next time around. And I think I mentioned exception handling as an example. Packages are another example of that. So our package support, the code for that was not, ported forward from our previous version of Clang. It was rewritten because we had specific things that we wanted to address in how packages worked under the hood. A lot of that was to do with how packages contain units, and those units are initialized and finalized. So if you have globals or other things where you want to construct or free as you load or unload, or you have different units and they have interdependencies or anything like that, we wanted to rework how units seem to interwork with each other, with a big focus on reliability, because codes in particular units, different files, can interoperate and rely on each other. And if you have initialization so that you're relying on some bit of code running before some other bit of code, that needs to be right. And so we had a big focus on that. In the past, you might have seen things where you might have let's say a Pragma startup or something like that. But you might have seen loading packages and perhaps getting an access violation or something like that. All the work we've done here has been to completely fix that, make it gone as a problem. There's a common theme I'll probably talk about a lot, problems that are gone. And so it's a long roundabout way of saying we've also had a lot of documentation explaining this. So I have one link on screen called Packages for the C++ new toolchain, but it has subpages. It has several subpages. I might as well actually show them since I'm screen sharing. Packages for the new C++ toolchain. This is the page, and this is an index. It talks about why you need to use Pragma package. Has this big thing about unit initialization and finalization, and it also has information about package import and export. So when you have classes that you want to make available from a package to your application, what do you do? How do you understand the behavior? What does this package keyword mean? And our recommendations, these are our best practices. This is how to be successful with packages. So lots of new documentation, and this applies fully to the, a lot of it obviously applies to all C++ toolchains, but this is written specifically for the new toolchain. I get really enthusiastic about this because I'm really glad to have this kind of thing documented, and I hope it's going to be really, really helpful for you. All right, let's talk about compile speed. So this has got a lot of interest from customers. One of the main reasons for that is that Clang is quite slow. Now, C++ in general is slow to compile. So in that sense, Clang is normal, but it does take time. And so things that we can do to speed up compile speed, or help those who are still using the classic compiler to move to Clang, can be really important. So the classic Win32 compiler is what's often compared to here. We call it the classic compiler, but it's the one that has its roots back in the 90s, really, with the last real work being done on it in the 2000s. Now, look, it's not a great compiler. We made the decision to move to Clang as the foundation for our compiler back in before my time, but I think it was about 2010, for very good reason. It's the classic compiler had really reached the end of, the end of where it could really feasibly technically go. And it's not very good optimization, and code gen is not great, and the exception handling can be a bit flaky sometimes. It uses x87 math Error messages, I mean, it has them, but Clang has much more useful error messages. It definitely can't handle any C++ libraries built in the past 15 years or so. So it's not really a great compiler to use. Now, we still ship it because some people still use it. And one of the reasons for that is that it is fast. It's fast because it doesn't do very much. But speed can be an advantage, and we know that. So we have been working heavily on speed for Clang, and then in the 12.2 launch, we made a big deal of this because we had inbuilt parallel compilation. In the past, when you compiled with Clang, it will compile one file after another. And now it will try and saturate your CPU, compiling as many files in parallel as it can. And that is on by default. It's known as -- jobs. We had an implementation of -- jobs before, but it was fairly clumsy and not easy to use. This new one is again completely reworked, a brand new implementation, and it is very efficient. To our knowledge, the underlying tech of how we've implemented this has the lowest overhead of any parallel compilation system for C++ on Windows that we know of. I could probably extend that to other platforms as well. So it's a very efficient implementation, and it's on by default. So basically, you install 12.2, you toggle over to the new Win64 modern platform, you click run, and it will just compile in parallel, saturating your CPU. So you can see why this has got a lot of people interested. In the past, people would often use Twine Compile, which is a wonderful add-on. Or they might use CMake, perhaps, or they might just try and put up with the previous Clang performance. We've seen a lot of people who did that. And now the default Clang performance is as fast as it can be on your machine. It's quite literally limited only by the hardware that you give it. So big focus on speed. But look, we hand waved a little, mostly because it was new and we didn't have concrete answers ourselves yet. Now, we had some solid data, but we also saw varying results. Now, there's always faster. Absolutely. That's the whole point. It's meant to be a lot faster. We could not necessarily state always, the best C++ parallel compilation in, for Windows in the world or something like that. And I'm still not going to say that today because there's a lot of work that we want to do on it. But what I'm going to do is share what we have and what you will get when you install. This was the slide. Well, there were several slides. This is one of the main slides from the 12.2 launch webinar. And the chart there, I think, is what's really interesting. We're comparing the classic compiler on the left and then a few other tool chains. And we created some artificial code. We wanted to write about 350,000 or 360,000 lines of code and across 5,000 files and test compiling it with different systems. And this is what we highlighted with this arrow. We pointed out that on the particular system we benchmarked this on, this particular benchmark was not only significantly better than other Windows toolchains, but it was approaching Classic in speed. And this is exciting, especially for those using Classic. But if you're using Clang, and a lot of our customers are using Clang 32 and Win64, then this is also a really interesting chart. However, we are still measuring and investigating. Now, as I mentioned, the internal approach is very efficient. The industry standard is a tool called Ninja, which is used with CMake, which we also support. And we believe we have a more efficient approach than that. But of course, that's efficient for the overheads. Most of the CPU time goes into actual compilation. The minimum we expect you'll get will be on par with Twine Compile, which we really appreciate and we think is a wonderful add-on. But we note that it's inbuilt and supported and on by default. You quite literally just install the new version, make sure you're using the new platform and click run. So we genuinely recommend giving it a go. Now on that artificial code, the chart I just showed you, we were obviously way faster than anyone else, but real world code, every time something hits the real world, it's never quite as good as a benchmark or a test. And we're often back to on par with other industry tool chains there, especially when we have STL heavy or complex code. Now, even so, it's a lot faster than before. What we're trying to do now is to research this. What is it about these particular code patterns? And what we want to do is to try and take advantage of the efficiency that we have, so that we can do more benchmarks on real world code and make sure that we see all the benefits of our architecture. What we can tell you right now when you install 12.2 is, yes, it will be fast for sure, and it will be fast roughly scaling with however much CPUs and RAM you give it, and it's on by default, as I've mentioned, so fully supported and fully integrated. Now, one interesting thing is that the more cores and RAM you give it, the more efficient it gets. And the reason is that there are overheads, and those overheads shrink comparatively based on the number of files. So really, if you give it a tiny little app, is really not the way to test it. You need to give it 100,000 lines or 1,000,000 lines of code over many files to really see the benefit. I mean, you'll probably see it from 5 files upwards, but you get what I mean. What the point is, the efficiency scales. Now, with enough cores, when you throw enough hardware at it, our tests do compile faster than Classic compiler. Now, that's not because Clang itself is faster. Clang is a much more modern, much more robust, much better compiler all around. I mentioned before some of the problems with Classic. It doesn't have any of those. All of those are turned into features and advantages that it solves. Now, with that is that it does more work, and therefore it's slower. But it's slower per individual file. And that means that the approach to speeding it up is to do the work in parallel. And that again means that the speed up that you'll get will be more and more visible the larger your project. So I have here a chart of a little test app, and I just ran this afternoon. And it was a small test app of about 6 C++ files, not very much. And this makes the overheads have a large impact. And I think that's interesting for a chart. And it's just run on a 4-core machine, actually on the computer that I'm talking to you from today. And I've broken the chart down here by various stages of compilation. If you build, so clean everything and start from scratch, you will build the precompiled header that's used and shared among all files that are compiled. Then after you've built that precompiled header, you go on to compiling the actual code, and that's every C++ file, one after the other. Then after you've done that, you have a bunch of object files and you link them together. So precompiled header takes a bit. Took about 9 seconds for me with this test app. That's the blue bit on the left. Then compiling these 6 C++ files took another 20-something seconds. You can see here that the timescale on the bottom went from 9 seconds, let's see, 37. So it's about 27 seconds, I think, to compile just 6 C++ files. Then took about another 5 seconds to link all that together. So this simple app took about 3/4 of a minute from scratch to get to the point where it ran. Now, when I toggle over to the new Win64, this is what we get. So exactly the same app and just the pure defaults that you get out of the box. Overheads. You can see the precompiled header takes about the same time. For me, it was 9 versus 10 seconds. And that hasn't changed. That's because that's a single core doing a single process before it can begin everything else. But the really interesting thing is what happened after that. And you can see here, by the way, when you have overheads like this, how those are going to matter less and less and less and less the more code you throw at it, because what we're interested in here are the red and orange bits. Look at the red and orange bits. Those are compiling and linking. So you can see that compiling was parallelized, and it was spread out over the 4 cores I gave it. It went down from 27.8 seconds to 5.8 seconds to compile everything in parallel, which is just under 5 times faster. This is on a 4-core machine. That's a massive, massive speed up. And then linking, well, we have a new linker, and it's a lot better and a lot faster, and it took 5 seconds before, and now it took just 1 second to link. Again, that was about 5 times faster as well. And what I want to demonstrate with this chart is that this is real-world code and it uses the STL. There is a bunch of overhead. So you can see that the more files you have, basically, the more important the red and yellow parts get. And those are the parts that are shrinking. It is parallelized, and on my 4-core machine, I got just over 4 times, just under 5 times faster. Now, here's the thing, that scales with CPU. So if I ran that on an 8-core machine or a 12 or 20-core machine, I could expect it to be much, much faster. To be able to measure that on a 20-core machine, I would need to have at least 20 C++ files, because otherwise a whole bunch of cores are going to sit empty and not have anything to do. So again, that's a reason why you need to throw at more and more code to really take advantage of the system and of the hardware that you run it on. Then the linker is just faster and better in general. This, I think, is a good demonstration of the before and after. Overhead, this bit scales. Basically, the more files, more CPUs, the more visible it will be. Our recommendation here is to give it more than 4 cores. Now, I was testing on a virtual machine. The laptop I'm speaking to you on has 8 cores. If I were using it the way we recommend you would, I would give it every core that this machine had. And more than that, we would recommend you give it as beefy a computer as you can. Go out and buy one of those 20-core machines if you can. We really genuinely recommend it. Give it as many CPUs and as much RAM as you can. The more of it you give, the more it will be able to take advantage of. We find with enough hardware, then, as we say, doing everything in parallel brings it down faster than Classic, which is a major thing, and we really hope is useful for those of you using Classic. Throw something beefy at it and get something that compiles fast. All right, on our standards and compatibility and our demos. So we targeted C++ 17 by default for the new toolchain. Look, we have a lot of people who are interested in C++ 20 and sometimes C++ 23. That's completely unsupported right now. The reason for that is that when doing a large upgrade work, and that includes when we give you new toolchain, the fewer moving pieces, the better. So for us, our old Win64 toolchain targeted targeted C++ 17. And so we kept that when doing the upgrade, because we didn't want to upgrade both the compiler and the RTL and the standard library and everything, and have a moving target for C++ standards at the same time. Although this is something that we will look at and upgrade in future. The main key, though, of course, is that BCC64X, which is the name of the new Win64 modern toolchain, is, of course, a much better C++ 17 toolchain. Specifically, one of the most highly visible areas is the STL, the standard library. We had a class of issues around things like std variant, for example, or other areas of the STL. Try the new one. It's really, really good. It is a much, much better toolchain. Now, what that means is that it's a lot easier for us to compile just random C++ code that you give it. Now, look, all of our demos are normally fairly small because we ship demos for particular small features. So it's perfectly reasonable just to have a demo. There's a few lines of code when you're just wanting to demonstrate a particular feature. And they're on GitHub. I'll show you actually since I'm screen sharing. In fact, maybe I have Windows always doing something when you don't want it to. This is github.com/Embarcadero. We have pinned up here on the top left Red Studio 12 demos. Click that. You can pull it with your favorite Git client or download it. And then you go to CPP. And the particular demos that I want to use today and that I'll show you are in this CMake folder. So that's where to find them. Now, customers have often asked us to support some specific C++ libraries that are really useful. Some of those are things like OpenCV, which is a computer vision or image analysis library, or VTK, which is about 3D graphics and data analysis. Now our customers work in a huge range of areas, basically every area you can imagine writing a C++ app. We have people writing C++ apps. But these kind of libraries, as you can see, are highly useful, in many areas. And we have been asked directly to support them. Can I compile OpenCV with C++ Builder? Now, we wanted to show you both how good 12.2 is and to answer, yes, you can use these now. So I'm sort of giving away the answer here by saying yes, but you probably guessed that was where I was going. We also want to show you just how good 12.2 is. Now, look, OpenCV is the single most requested library that we get. We have a spreadsheet of dozens, but OpenCV is by far the standout winner. VTK is probably second, and it turns out to be a dependency for OpenCV. So if you want to get OpenCV working, you have to get VTK working as well. And in total, it's about 14 million lines of code. Massive, difficult, problematic C++ code. And if you printed this out on paper, and I hope I did the math right, but I have checked several times, and based on standard novel page size, standard number of lines per page, and that kind of thing, as you would get with a normal book, if you printed out OpenCV, it would be 45.5 meters high. So this is a big library, and it's really something for a toolchain to tackle. It's not something that is necessarily easy for any C++ toolchain. So I just want to give sort of like a visual example of the size here. So if you see down the bottom of the screen, you can see an old demo that you can actually can't see on screen because it's a few pages, so it doesn't show. And then there's me, a little human figure. I just want to show you how big OpenCV is and really communicate the scale here. Here, compared to me, is the Christ the Redeemer statue in Rio. And compared to that statue, here is a Boeing 737-800. It's about 39 meters long from tail to nose. So you can see both these things are significantly larger than I am as a human, and significantly larger than any of us are. And this, on the very far right, is what OpenCV would look like if it was printed out and stacked page on top of page. It is a very large library. 14 million lines of code is a lot of code. It's actually just under 15 million. A lot of really difficult code. So obviously, we are here to be useful to you, our customers. And OpenCV was the single most requested library, and we really wanted to have a toolchain that we can just sort of look at a request like this and go, oh yeah, give it a go, it'll work. And that's what we've done with 12.2. This is one of the reasons we're so excited. Everything just works now. So more than that, we just turned this into a demo. There are a whole number of ways we could have made OpenCV available to you, but we just turned it into a demo, mostly just because we can, because it works. We thought one of the most effective possible ways to do that was that all those little demos that we had that show particular features that are a few lines of code long, well, we're going to upgrade with 12.2 from perhaps 50 lines of code in a demo to 15 million lines of code in a demo. And we hope this really communicates one of the reasons that we feel so good about the new toolchain. And let me show you the demos, because I mentioned before finding them here. Now, I'm not going to talk about CMake very much. We talked about that at the launch webinar. But I do have a folder here that has my CMake demos, and this is what you'll get when you download them. And you can see the whole heap of things. You can build a console app or a FireMonkey app, a couple of other libraries like libsimdpp. You'll notice here that we have VTK and OpenCV. And we just provided a batch script. So look, OpenCV, because it's huge and there's 15 million lines of code, will take a couple of hours to compile, even when it's using CMake and Ninja and using every core on my CPU. So I'm not going to sit here for 2 hours showing you that it builds, but it does. And you can see here, if I go to, if everything comes out here in the install bin folder, I have a bunch of the libvtk libraries here, because that's what I just built. This stuff works. But I just want to show you CMake in general. So I can have like a make VCL script you can open these bash files and have a look. Really, all they do is just set a bunch of variables, saying, it's a Windows app, and to link against the VCL and to have dynamic packages, so static and that kind of thing. And CMake will run, and will identify what we have, and then we'll start building. And this is using Ninja, and then hopefully in a few seconds we'll have a VCL app, and it will give me a sign of success. There we go, it's linking, and it's done. So this was the short demo, but the point is you can also run something like make OpenCV, sit here and wait for a couple of hours, because there's 15 million lines of code, and then at the end of it, you will have a copy of OpenCV. So we quite literally turned our most requested library into a demo. Again, mostly just because we could, and we really wanted to emphasize to you, this is a good toolchain. It really is. So something else we've been working on, and I'll come back to more about Classic later, the in IDE productivity, code completion works a lot better than it used to. It's powered by Visual Assist now. We do recommend checking that out. If code completion is of interest to you, and of course is a really useful tool, so we expect it is. In general, just want to give a quick talk about Visual Assist, because we've been talking about this for about a year. In fact, it was just over a year now when we first integrated the first version of it into C++ Builder. Now, without hyperbole here, but it's difficult because Visual Assist is genuinely really good. But Visual Assist started life as an add-on for Visual C++, and it makes the Visual C++ IDE better. And so if you use Visual C++, you have to pay extra to buy Visual Assist. And Visual Assist is a productivity plugin. There's a whole bunch of really useful things. The main things are navigation. It makes it really easy to move around your code and to find the bits of code you want. Find the code that relates to the code you're looking at and jump there easily. And also refactorings. Refactorings are really important. Many people have asked us for inbuilt refactorings in CBuilder for a long time. And Visual Assist was the path for us there. Now it is constantly the highest rated productivity plugin for the Visual Studio Store. You can see it there. Took a screenshot of the highest rated things. One of those is a productivity plugin for navigations and refactoring, and guess what? It's Visual Assist. And it's consistent. It is always very, very highly rated. It is quite literally the world's best tooling for C++, and we are building it into C++ Builder for free. Don't have to pay extra. You get C++ Builder and you get Visual Assist. Now we started off with some really useful navigation tools and refactorings, and we've added either quality or features on sort of a TikTok basis every release since. So each release, you can expect to get more and more Visual Assist functionality. I thought I might just give a quick demo. Again, we've done this in some of our product webinars, so I won't spend a great deal of time on it, but I just want to give you a taster of why it's so exciting, why it's so good. So I have an app here. This is the same app that I compiled earlier, actually, when I showed you the performance charts. So let's try something. So I have some code here, and it has a few different headers. I'm including map from the STL, and not much else. There isn't much coming in here. Now let me try typing something. So numeric limits lives in another STL header. Now you notice that it's completing that even though I haven't got that header included in the code. That's because Visual Assist is smart and it can complete more than you expect. But anyway, if I type numeric limits int, I might want this for some reason, such as to initialize a variable with numeric limits int max or something like that. Here's one of the slightly cool things that Visual Assist can do. Once I've done this, I need to scroll up here and include limits, but I can just right-click this and go to refactor and say add include limits. It knows where numeric limits lives, it knows which header it is. I just click that, and then it will go, and bam, here I have the right header. Imagine doing this in a file that's 1,000 lines long. You don't want to have to constantly scroll up to the top and add headers. You probably don't even want to remember what header something lives in. you know the code you want to write, might as well just write it, right-click and make it work. This is an example of the kind of useful thing that the Visual Assist does. I'll try and show you one other thing which I have talked about quite a bit that I happen to really like. So let me open. I just opened the header there, but let me show you something else. If I click Go to Related here on the header, obviously I can open the file, which I just did, or open the folder. But I can see all the headers this particular one includes, which is quite useful. And I can see which headers in my project also include the same header. Again, neat and useful, and just helps you navigate. And this is one of the hidden features. I don't think we even mentioned that in our webinars. But anyway, FireMonkey, and let me go to one of our main headers, like probably std controls or something. And this is a massive header. It's many thousands of lines long, and it has a lot of a lot of classes here. And if I control click, I get a Visual Assist feature called Go to Related. And it can show you all the base symbols. So let me see if I can find a better one here. What this is doing, though, is it's navigating the class hierarchy, and it's saying this virtual method here, apply style, is also declared an ancestor, T-starred control. And I'm overriding that. So I can click there just to go to it. And let's try control clicking here on the ancestor and seeing what it pops up. Okay, it's showing a bunch of derived symbols. So it's showing me now, again, in the class hierarchy, and this is passing all of FireMonkey, and obviously works with VCL as well, and your own code as well. That's the whole point. Okay, what are all the places where this virtual method has been overridden? This is really useful to know because we rely heavily on object-oriented behavior. And how else would you figure this out? You'd probably do a kind of find in file search for the name of the method, maybe trying to put in how it's declared so that you get the declarations, not where it's implemented, and then just try and search and find them all. I mean, here you just control click and it will tell you. This kind of thing is really useful. It works for classes as well. So if I control click on any particular type name, you can see here T-control has a bunch of base classes, and you can see their hierarchy has a whole bunch of derived classes as well. You can navigate to the constructor. You can go to a member. It'll show you all the member fields and properties, all sorts of stuff. Other things, there are different searches. Obviously, we have things like find references and other refactorings, by the way. We have 7 different refactorings now in C++ Builder. Massive difference to a year ago. Like, we're on a roll here, guys. Obviously, you can rename and you can add include, which I showed you, and you can create methods in various ways. I'll get onto extract method later, actually. You can introduce a variable. If you have an expression, you say, okay, this is messy code. This expression should be pulled out into a variable. That's how you do it. Just select it and turn it into a variable. Create some usage where you can type something that you want to work and it won't work yet because it isn't defined. And so then create from usage will define it for you. But there's also things like find symbol. If I uncheck all the options so it shows everything, then it will show me all of the symbols, 240,000 or so available in all of my headers, and I can basically search through them incredibly fast. It was even fuzzy search. So yeah, Visual Assist is a really good productivity tool. It has so much stuff. It has all these refactorings, 7 of them to date. And a lot of these things with the smarter icons here, go to member is the one I showed you earlier, same as control clicking on something. It'll just pull up everything useful that you can find. So okay, let's go to related. Go to member is where it pulls up all the member fields and properties of a class. All of this kind of stuff. Really useful, just built in. Makes it really easy to move around your code and modify your code. And modifying code like that is really important to keep it up to date. Keep it working well. Again, like 12.2 added a whole bunch of stuff for Visual Assist. Pardon me. Really exciting stuff. We're really trying to communicate here that we're turning C++ Builder into a really useful IDE. Quite literally, the world's best tooling that other people pay extra for, we're building in. And you can use today. It's already there. All right, back to the new toolchain. Look, there are a whole lot of reasons to use the new toolchain. I hope I've communicated a lot. We have targeted all of the problems that we knew about with the old toolchains, whether classic or Clang. So every single one of them, we have really tried to address with the new toolchain. As I said, it took 2 years to build and to do this. Okay, but we have aimed at everything that you have told us, and we have tried to fix all of it and all at once. We've had a real approach of at every point just trying to do it right. And the idea there is that it's reliable, and that if you have had annoyances before, we want to tell you, upgrade and try it out. And we really hope that when you do that, you will see the results of our work. But there are many other advantages as well. Much better standards compliance, which means you can just throw in other C++ code, as I just showed. But it can also handle so much more code. Your linker is really wonderful. Not only is it a lot faster, but it can handle when you give it more. You can compile gigantic apps really easily. The code gen is much better. You can get some really heavily optimized code. It's one of the reasons people use C++ is because it produces really fast apps. Produces really, really fast apps now. Like, your customers will love this. And what's more interesting, especially in today's environment, is much better code security. Many more options to detect errors and bugs in general, but also errors and bugs that can lead to security issues. Now, all of us want to write high-quality code, and we want to have bugs pointed out so that we can fix them. But also, many customers, especially if you're writing apps with particular markets, you might be getting questions about security and that kind of thing, and you want to run a tool like this that has such a comprehensive set of warnings and diagnostics, can let you feel a lot more confident in your code when you compile with the new toolchain. I tried to summarize this as like quality, correctness, performance, and security or safety. The real message is just that every area of this has been built to be better. All of it is better, and that's why we're really trying to communicate this and suggest that you try it out. But you might also ask why we're emphasizing this now. Well, the first obvious reason is that we just finished it. We released it 6 weeks ago. We're really trying to get the news out, and we really want you to test it out and try it. So that's the obvious thing. A couple of the less obvious reasons that we're emphasizing this. Now, when you install 12.2, the latest, you'll get both the old and the new Win64 platforms installed at once in parallel. You can see that in the screenshot on screen. And you can just double-click one to toggle. Windows 64-bit is the old, the legacy one, and Windows 64 Modern is the new one. Now, this is intended to make it easy to upgrade. You can open your projects that are already 64-bit and just toggle back and forth between the two. If you have any questions about behavior between the different code, it makes it a lot easier when just within the same IDE you can go and compile and debug and that kind of thing. However, the new toolchain is the new toolchain, and the old one will go. It won't stay forever. We try in webinars like this not to talk about the future or give a promise, so don't take this as any kind of commitment. But it would be reasonable to guess it would go into the next major version and be replaced by the new one fully, because the new one is a full replacement. And the only reason we're keeping the old one around, because it is not nearly so good in every way, the only reason is to help you upgrade. And so we would recommend that if you are using Windows 64-bit already, now is the time to upgrade and to take advantage of both of them being present in the same IDE. The other thing, of course, is just that we're proud of it in general. I think our team has done a wonderful job, and I'm really grateful to them. And we really genuinely suggest you try it. Another less obvious reason, of course, is to ask questions about Windows 32-bit. Now, in 2018, we delivered a Clang upgrade, and that's the Clang toolchain that you've been using up until now. And we shipped that for 32-bit Windows first and 64-bit Windows later, about 6 months later. Now, back then, there were a lot more people who were building 32-bit apps. So a lot more customers were targeting Win32, and a lot more applications were being built with Win32, and that's not the case today. We see a lot of people using Windows 64-bit, and that's one reason why we put the new toolchain on Win64. Also, because Win64 is, is where things are these days. The first version of Windows that supported 64-bit apps was a 64-bit build of Windows XP in April 2005. That's 19 years ago, and it's been mainstream for well over a decade. And so 32-bit apps are not really what people are building these days, unless they have to, or unless they have an old code base. So valid reasons for it, and we know that. What we've been told by our customers is that most people who still use Win32 with C++ Builder today do so because the classic compiler is fast to compile, or they prefer debugging, and we have tried to target both of those. I talked a lot about compilation speed earlier. Clang is always, because it's a much better and much more thorough compiler, individually, file by file, Clang is always going to be slower than Classic. But taking advantage of parallelization, we can bring that total speed down for compiling your entire software way down, scaling with the hardware that you give it. And I haven't talked very much about debugging, but we do have a good debugger. We're using LVM's debugger called LDB in the PDB debug format. And we're working to make that a really top-class debug experience. So we're targeting both of those reasons. And the other reason, of course, is simply that you might have a 32-bit app because you have always had a 32-bit app, and that upgrading can be work. And I'll try and talk a bit about that later. What we want to telegraph, though, is that the new platform, which is a Windows 64-bit platform, is the future. It's the future that's here now because we're shipping it. And there's a platform worth using. And that if you're on Classic or Clang Win32 or Win64, we do recommend upgrading to the new Win64. This is the toolchain to use, basically. So why are we emphasizing this? Well, look, we've run a lot of webinars over the past year and a half and blogs as we've been talking about this, and we're trying to share stuff. Look, if people ask me as the product manager, is this thing absolutely perfect and bug-free? Do you have a 0 bug count in your bug database? No one does. But what we are seeing is utterly and completely different from the previous toolchain. Completely different. And so what I want to tell you is that CBuilder 12.2 with this new toolchain is massively better in every way. It's a huge advantage to you, and it's the future, and you should use it now. So, like, absolutely yes to every question or reason you could have about what toolchain or why. We really want to communicate this is the one that we believe that you should use, and this is the one we believe that you can use. All right, some really, really ultra concrete info. I want to share some stuff from customers who have done upgrades, conversation with support or things they've told us. Starting off with something that we recommend. So tip number 1, when you use this, use the absolute latest. So after releasing 12.2, we released a new installer, what we call the 12.2 inline install, and that includes a bunch of fixes around packages, some Delphi packages and component packages. That's the one you should install. That's because releasing as a patch was difficult and running as an installer is easier. So make sure that you download the 12.2 inline install, either an ISO or an online web, but the name is the 12.2 inline install, and run it. It gives you 12.2 as the new build. That's the baseline. Then after that, we released a second patch, which was actually, this one was for C++, and it fixed 2 issues. an issue opening projects that will show a dialog that was annoying, and a regression. So after installing 12.2 with the inline install, make sure you install RAS Studio 12.2 patch 2. Now look, this sounds complex, and I regret that, but this is really worth it. Basically, it's not too complex because on the welcome page, you'll see a patch available button. If you don't have 12.2 installed, just download the latest installer, which is the only one we make available to install, and run it. Then you're good. Then on the welcome page, click this patch available button, and it will install the second patch. It's actually really not very hard. You basically keep on clicking this patch available button, follow the instructions on screen, and you'll end up with a fully up-to-date IDE. So it's not nearly as complex as it looks. But I just want to emphasize the fixes that we put out are worthwhile. I know there are only 2 bugs, but they're important ones, and we want you to start with the best and use the best. So make sure that you install the latest and install the patch 2, which fixes 2 issues for C++. Next, in terms of upgrading, handling the old runtime library. Now, as you might know, if you've read our blogs or seen our webinars, we have a new runtime library. I mentioned we have a new C runtime library. We also have a new C++ runtime library. Now, our new toolchain focuses very heavily on doing the right thing. It's standards compliant. Now, our old runtime library, which just you do not use anymore, we have a brand new one, both for the C and C++ levels of an application, completely replaced. And the old one had, was code that had started several decades ago, and so it continued to have methods that were originally added from before C++ was standardized, methods and classes from Turbo C and Turbo C++. And the new one doesn't have those. So what will you see if you happen to be using one of these? Well, you'll see a compile error on some method. And when you search, when you try to Google for it, you probably won't find very much because they date back 30 years. Here's an example. A method called randomize, which dates from, I think, Turbo C. Google for it with term C++, and you won't find it, at least not in the top results, but you'll find something similar. This is a big hint, because anything that's should exist when you compile, you'll easily be able to find on Google. If you can't, then there's a hint at something from 30 years ago. And you'll have this reaction, okay, this is not really what I searched for, it looks similar, and then you'll click it, and then you'll probably find what to replace it with. Now, we were quite worried about this before we released. We believe we're doing the right thing by releasing the initial version, is focusing on getting it right, standard compliance. I've been keeping a real ear out ever since then through support cases and that kind of thing, reading forums, that sort of stuff, to see is this actually a real issue for people. And we've seen very, very few reports about this. Either very few people are sort of accidentally using methods and classes that date from that really old time, or people have found them really easy to replace when upgrading. I want to give an example of the kind of thing, though, which I showed in the screenshot before. This is the single most common one that we've seen, which, when I say common, I think I've seen 3 reports of it. The single most common one we've seen is randomize and random, which are 2 methods. Randomize initializes a random number generator, and random gives you a random number. These don't exist anymore. Now, CBuilder has methods randomize with a capital R in the Delphi RTL, and random to do the same thing. And the standard C++ method called strand, which will generate a random number. Or you might want to check out the random header, which has a whole bunch of really interesting functions and different ways to generate random numbers there. The message here is that, look, you should check your code, but usually everything that we know of is very easy to fix, basically because all these things were added to Turbo C or Turbo C++ before the language was first standardized in 1996 or so. And that means that when the standards were written, they included all this functionality, and they might have renamed something or standardized something that was slightly different, but that let you do the same thing. So random within a range can be replaced with stdrands modulo that maximum, for example. You should obviously check that that code is correct for you. Please do that. But look, we have seen very few reports of this in the wild, and we haven't seen reports of anything particularly hard to fix or replace. But we would love to know what you're running into. We're considering writing what we call a shim library, which is sort of like a backwards compatibility library, if it turns out to be necessary or useful. And that'll be strongly based on feedback. So email me. However, the message is that from everything we've seen so far, this is really not much of an issue, and when people are running into something, it's very easy to move past. Tip number 3, large files. So the old Win64 using C++ IO streams had a 4 GB file limit. Now in 12.2, although we have completely different standard library and completely different IO streams implementation, we can support large files. You need to define a particular macro, which is there on screen. We might enable that by default in future, but it's 2024, same as we shipped a 64-bit binary for our compiler. It makes sense to support large files. So you can do that if you just define this macro on screen. Tip number 4. Look, take advantage of security and correctness. This comes from some solid feedback from multiple customers. And I have actually multiple versions of this tip, so there are going to be several sides here. Now, the new compiler is much smarter, which is really good because it produces much better code, really fast code, but that's because it's really good at optimization. But that means it can optimize way more things, and it assumes that your code is correct. And if you have code that was subtly not correct, then you might find it doing something unexpected. That would be a concern, of course. But the new compiler is also much better at warning you about this. So everything that we know of has an associated warning. Now, the single most common one that we've had from many customers, so common that I wrote a blog about it, is that people had uninitialized variables. They declared a variable but didn't initialize it before using it. And this kind of thing is something that the compilers have warned about for years, but it is also very easy to overlook. And because code will appear to work, now you'll get random data, whatever was on the stack at that particular location where the variable happened to be in memory. And depending on your program behavior, it'll probably work for years until just one day it doesn't, and then you won't know why. Now, Clang is a lot more strict about this now, and if you have an uninitialized variable, it'll actually insert what's called a trap. It'll say this is undefined. It is not legal C++ to have an uninitialized variable and then use it before you initialize it. The optimizer relies on a guarantee that a variable is correctly initialized in order to make certain optimizations. And it makes that guarantee by, if it's not initialized and then it's used, it will insert what's called a trap, which is at runtime a crash. And again, this might concern you because even if you have incorrect code here, you might run it and then instead of pure luck, meaning that it worked before, now it will crash. And obviously this is obviously not ideal. Look, Clang will warn you about this. It will compile and it will tell you every single place where this might happen, and then you can fix it. The compiler is not silent. The compiler will tell you. The compiler will tell you everything you need to know. And you can find these before the optimizer does, and you can fix them. Now, we strongly recommend compiling with all warnings, the -w all, as a minimum baseline, and just fixing whatever it says. Because 99.99% guaranteed it's a real bug if the compiler finds it. And we have seen bugs where people were not convinced they were bugs, but then they actually turned out to be, but it was difficult to understand why and difficult to understand the complex behavior. So we just generally recommend that this compiler is really good at finding problems in your code. Now, the interesting thing here is that the reason to do this is not so much because the new compiler will optimize something in a way that causes a problem if you have bad code. The really interesting thing is that a lot of the issues that people have are issues that are present but not always visible. And how many times have you had a bug that occurs 1 in 1,000 runs, or that a customer tells you about and you can never track down, or something like that? There's something going on in your app and you don't know why, and you can't reproduce it, and it doesn't make any sense. Run with these warnings. We've had several customers, a lot more than I expected. Like, a lot of people tell us that they have upgraded to the new toolchain, and that the new compiler has found bugs they didn't realize they had that have been in their code for years. So just by virtue of upgrading and running with these warnings, you will make your code more robust. And I want to emphasize the value here, because it might seem that you upgrade and then you run with warnings and it's a bit of work that you don't want to have to do in order to fix the warnings. Absolutely not. Whatever you're warned about will be valid, and it will be worth fixing. We are seeing people who've told us that they have had that example of things like 1 in 1,000 times. These are the kind of bugs that people have had, and they've sent us feedback where things like this were happening and they're not happening anymore. And the reason is because they took advantage of the new compiler. So we recommend this. Upgrade, run with all the warnings, fix them all. Let the compiler do its thing, and fix every issue, and take advantage of having better, more robust code. Now, look, this is the kind of thing I talk about quite a bit. I want to talk about a few different aspects of this. There's also compiler options around safety, and there are 2 really good things to read. I'll put the links on screen in a moment. One is the Open Source Security Foundation's Best Practices group produced a document recently called the Compiler Options Hardening Guide for C and C++, recommended switches. Many of them are for Clang. And there's another really good blog post called Leveraging Your Toolchain to Improve Security. Now, of course, security is a big buzzword these days for good reason, but also safety, whether or not your application needs to be secure in terms of not providing opportunities for people to hack it, and avoiding buffer overflows and stuff like that. In general, everything you do here improves safety, and it improves the robustness of your code. Your code will be more reliable. Those are the links on screen at the bottom. I've just pulled out a few interesting things that you might want to know about. For example, printf statements can be really common to accidentally subtly send the wrong data type to it. Not always as obvious as you're sending a string when it expects an integer, but maybe even just send the wrong size data type or something like that. There are multiple switches to warn you about that. Or did you know that in some cases, when you have an if check for a null pointer, if something is not equal to null, then go on to a block of code. There are times that the compiler can optimize that out, that's if it thinks you have already dereferenced it. Now, this is because it's optimizing heavily, and it thinks that if there is no way that the pointer can be null, then it will optimize out the null check. But you can keep that. You can keep that as a safety mechanism with a particular flag on screen. Things like this. Read these documents. Take advantage of what the toolchain provides you. Another thing, and I'm still on the same tip 4, except it's tip 4 3/4 now. Look, we've already recommended just compiling with all warnings. But if you don't, check out the Clang documents on diagnostics and at least search for the word pointers and null and things like that. There's a whole bunch of stuff that will help when you're moving between bitnesses, especially if you're downcasting a pointer to a 32-bit type accidentally or something like that. And this is important if you're trying to upgrade straight from Classic, for example. You're upgrading an entire toolchain and bitness at once. Run with all the warnings. The compiler helps. The compiler helps you. really does help. Run with everything, and fix everything it tells you, and it will help a lot when you upgrade. All right, really on to the next tip now. You will want to separate, or rather not mix, different types of exception handling. Now, exception handling is kind of arcane, and you may not even really be paying a great deal of attention to the different types of exceptions your application has. But you will most likely at least have both C++ exception handling and structured exception handling code in your app somewhere, possibly different places, but it's very likely you've ended up with code like this. And hand-waving something complex that even though I work with compiler engineers, I still don't understand fully. Because it's really complex. These are two different exception handling systems. One's a language one, and one is an operating system one, basically. A different mechanism. Trying to mix these two in the same methods, the same, what's called a frame, basically, is a bad idea. Now, this is what it looks like. C++ exception handling is try catch, basically, and then SCH is underscore try. You most likely use try finally through this, and don't mix these two. Now, look, if you try, you'll get this. It'll tell you that you can't, and it'll tell you where and why. Of course, you don't want an error. You want to fix it, and you want to fix it with as little work as possible. And you probably don't want to have to rewrite a bunch of code when you're upgrading, right? I mean, who would? I'll get onto that. First of all, why? Okay, two different types of exception handling in the same frame. Absolute mess trying to do CodeGen. It is not supported in any C++ toolchain on Windows. If you had code like this and it appeared to work before, it was super dodgy, don't do it. You probably had issues in there in the CodeGen but didn't realize it. Again, you might pick up a bit of a theme here of just improving code quality through upgrading. This is another way. You might not even know you had bugs there, or exception memory leaks, or something like that. But you will have, even if you don't know about them. So fixing this will improve your code. However, you might use this in a few places, and it can be, annoying perhaps to try and pull methods out, because the best way to handle this is to pull each part of those out into a separate method. One method calls the other. Perfectly okay to have different exception handling in different methods that call each other. It's just mixing them in the one method that's not right. So we specifically added a specific Visual Assist refactoring in 12.2 because of this, to make it really easy for you, and that is extract method. So if you have code that looks like this or similar to this, you can simply select it, right-click, refactor, extract method, and it will pull that code out into a new method for you. And yes, it handles all the parameters. So all like local variables or anything that bit of code is referencing will turn into parameters in the new method, and they'll be correct if they need to be references and so forth. Really easy to clean this up. I'm going to show that other side again. Quite literally, just select select the code you need to pull out, refactor, extract method. It will do the right thing. It'll add the declaration to the header and everything, and get a new method and solve this. All right. Tip number 6: handling libraries. This is kind of a magic thing, so I gave it like a magic unicorn sparkly bit of text there. Right, libraries. Your .lib file or a .a file might be a static library, might be a DLL import library, something like that. We've seen a lot of people who add them directly into the project. So you can see a screenshot there. I have an application, and the selected item down the bottom happens to be, you have a .a extension, could be .lib. Will be .lib if you're using 32-bit, for example, like Classic. But it's a static library and will be linked in. Now, you have one application, but you might have multiple tool chains and multiple targets, especially as you upgrade. But you can't specify, you can't separate the libraries here by target. You can add a library, but your Win32 one won't work when you try to compile for the modern. You can't link a 32-bit library into a 64-bit one. So what do you do when you have a library like this? Look, the answer here is to use auto-linking, which is magic. Auto-linking lets you write a particular pragma in a C++ file that you use, the one I recommend for static libraries, and we have documentation on this, really good documentation. Hash pragma comment lib, and then your library name. Now, it is magic because it will find the right library based on that name, because there are actually a lot of potential variants. There are different extensions, like lib and .a, but there are different prefixes. The real name of the library for a library called my library name might actually be lib my library name.a. And you don't want to have to if-def this kind of thing out your code and say, okay, if it's Win32 and it's classic, then link to this one. If it's Win32 and Clang, link to that one. If it's Win64 modern, link to this other one. That is not good. And that's why auto-linking is magic, because it just does the right thing. So you just tell it pragma comment lib and the name of the library without the extension or anything like that, just the name of the library, and it will find and link in the right one. We have a lot of documentation on this. It explains everything. It explains how it works and why it can do the right thing and how the link's there on screen, but just search the doc wiki for auto-linking. This is the way to handle it. If you happen to have any libraries in your project file, link them to the project file, add them in a C++ file with pragma comment lib. All right, tip number 7, and we're getting to the end here. This webinar has taken a little longer than planned, but there's a lot of content. Tips on using the new compiler. The command line version is called BCC64X, so you'll hear us refer to it both as the modern compiler or as BCC64X. First of all, the more warnings, the slower it compiles. Quite literally, the more warnings it emits, it actually has a noticeable impact on compile speed. So I've tried to convince you to run with all warnings on and then fix them, because the new toolchain will really help your code quality. But there's another reason, which is just, if you're getting a whole bunch of warnings being printed out, fix them and it will compile faster, really. Another tip, like if you see a crash and the memory is a bunch of H0 bytes, the new runtime library marks freed memory. And if you see this pattern, then you're accessing memory after it's been freed. So you know a particular bug is there, and this will help you find it. At absolute minimum, if you can't build with WAll, please build with W uninitialized, because code bases have been around for a long time. It's easy to have uninitialized variables, and they will cause you problems. Please build with that and just fix them. Initialize them to a value. Finally, to test the new compiler in code, hopefully you won't have to do this. But if you do, this is our recommended way to do it. Have an ifdef for __ codegear C, and checking the Clang major version is greater than or equal to 15. This will apply both for this toolchain and for our future ones. So if you need to ifdef any code, while upgrading or to keep 32 and 64-bit working together or something like that, use code like you see on screen. Finally, documentation. Look, we've actually added a rather large amount of documentation on the new toolchain. You can find it on our doc wiki. BCC64X is the general page. There's a page with a huge title, Modern C++ Features Supported by RadStudio Clang Enhanced C++ Compilers. There's a couple of links in it to our language compliance status pages, so you can check there what we support and what we don't. If you're building Delphi packages, if you're a vendor who makes a component and you want those components to be available to C++ customers, we have a special page for you on how to do that. We have the documentation I mentioned earlier on packages. They were often quite mysterious and not well documented, especially for C++. Well, we've fixed all that. Now fully documented with a bunch of recommendations and best practices. And we have a troubleshooting page. And most of all, the biggest tip I can give you is to email us. Like, we and our support are here to help. So email us. We want you to be successful here. So summary of all the tricks. Install the latest 12.2 and patch. That should be your foundation. There are easy replacements for any 90.0 RTL methods you have, but let us know what you find, because maybe we should add in a shim library. talk to us. We really want to hear from you here. You can access large files. It talks for a lot about the compiler and how it can find a bunch of bugs for you. It really can. And we've had so much feedback about people who have had bugs for years that they've fixed because of the new compiler. So take advantage of that. Split different types of exception handling, but we make it really easy for you with that refactoring. Hopefully you won't have very much here, but even if you do, we've made it as easy as we possibly can, like inbuilt tooling to help you split that out. Library handling, use auto linking, absolute magic. And then a few tips just on using the compiler itself. Faster compiles, the fewer warnings you have, and what happens if you have a use after free, and documentation, and to email us and more. Look, we're really excited about the new toolchain. We really want to communicate that it is the future and it's here now, and it's the one that we think you should use. You should try it out now. You should upgrade. It will help you in many ways. If you're encountering any issues with the old toolchains, try using the new one. And if you're not, the new one's just so much better and so much higher quality, and the codegen is better, and everything like that. It's so much faster. Try out the new C++ builder. We are really excited about this. We've put an enormous amount of work into it. Years of work. It's been hard work. And our engineers have done an amazing job. And we really think you should try it out. And so that's why. Look, there are so many reasons, from the quality or the parallel compilation to the new standard library, to how easy it is to use third-party libraries like OpenCV. And I just want to remind you of that demo that is bigger than a Boeing. We did that because we can. Like that's the new toolchain. The best in the world productivity tools that we're building into C++ Builder. Like in general, C++ Builder 12.2 is something that we strongly recommend upgrading to because it's really useful for you. And the new toolchain, this is the one that is going forward. We think there are immense advantages to it, and we really recommend that you upgrade. And finally, stay in touch. Look, email me directly. You can see my email on screen. And if you upgrade and you happen to run into issues, people can have a million lines of code. There's going to be something in that million lines of code, but we're here to help because we want you to be successful. We believe in this toolchain and we want you to be successful using it. So get in touch with us. We want you to be successful, and we're here to help. And folks, that's it. I talked a lot, but the overall message is we're excited. And I hope now that you are too. So Ian, if you're there, maybe you could take over emceeing and
I am here.
Any questions?
I'll remain as a voice because I think you've got the screen, and plus, well, you're dressed nicer than me. I've got my Embarcadero top on, but you're looking nice and cozy and very C++y. I like that. Yeah. A lot of
winter now, so it's time for the turtlenecks. So yeah.
Yes, yeah. Well, it's Dallas here, so it's always t-shirt weather, even in the winter. So the good news, a lot of love for the product, and I've answered quite a lot of the questions that I could answer, but several people said they're going to upgrade, and the ones that have not said definitely I'm going to upgrade have said I'll download the trial and try it out. So I'm really pleased. Paul Jackson says a great presentation for sure. Roll Jansen says thanks, blah blah blah, and a few other things as well. Great stuff. So I flagged some questions that I didn't know the answer to. Are you able to see the questions? Because I know sometimes on your setup you can't, because it's a
no, I can't because I'm screen sharing. What I might ask you to do is perhaps you could just screen share a slide or something like the last slide, and then I'll be able to pull up my GoToWebinar admin panel and.
Oh, okay. Yeah, I suppose let me just try and do that. I actually think we can just turn the cameras on. If I change to me, this. And then say change presenter. I think as long as I do this,
so I can see the question list now.
Yeah.
Folks, I
Okay.
want to thank you for sticking around. It was a long webinar, and I really hope that the info was concrete enough for you. We really wanted to share some really concrete info.
Yeah, cool. Okay, so you can see the question. I flagged the ones with, can you see the priority flag? Because again, let me just
Yes.
explain to everybody. We're using GoToWebinar. This is my least favorite platform for streaming. Restream is way better. I'm sorry, GoToWebinar, but look at what Restream do, copy it, and we'll be very happy. But anyway, we know that there's some differences with the Mac and stuff like that, and sometimes David can't see the questions. So if you're able to see the flags, if you untick the show answered questions option, then you should see the questions there.
Sure. So I see the very first question was about compiling try catch and try finally in the same function, resulting in an error, a compiler error, which was actually asked an hour and a quarter ago, and I only just covered it about 10 minutes ago. But yes, that's for very good reason, because mixing exception handling is complex. Mixing two different types of exception handling in the same code is not something that any compiler on Windows supports. And so we built in the extract method function to make it really easy for you to just pull out a segment of it and put it somewhere else in another method. And then that works. So it should be straightforward to deal with that.
Cool. Okay, so
Next question. Sorry, go ahead.
Next one is by Senador Jariez. I cannot pronounce your name. I'm so sorry if I've mangled it. Does the COF format support mean that we can use .lib compiled with VC++ without doing a conversion? I think you said everything.
Not really. I mean, the idea is you should be able to run basically any code. Most of the problems we've had when we've been using third-party libraries with the new toolchain is that they have some if-defs in there for the old compilers to work around things that aren't necessary anymore, and we have to go and remove the workarounds. So yeah, in general, we should just try recompiling code directly in CBuilder, and if you see weird things happening, then go in and fix the defines around it or something like that. But the COF format is basically because it's what everyone does. Sorry, Ian, what was that?
Yeah, I mean, that was the thing you kind of stressed as well, which is, look, this just works. That's the weird thing. People say, oh, well, I'll use C++, Visual C++ or whatever. Okay, I get that, but actually, most of the C++ stuff you want, if not all of it, is going to work, and that's why there was so much effort put into the Clang compiler or CLang compiler, however you want to pronounce it, because it works. And the fact, as you demonstrated with your graphic, I like with the jumbo jet, the aeroplane and the Chrysler Redeemer statue and a tiny little David, and you're not tiny. Being able to compile 9 million lines of code for the Open CV library is a really good test of compatibility, because there's some crazy stuff in there. Rocket scientists, taxing code, and I think that in itself is a validation of the fact that this is definitely the step in the right direction, because you can compile that. There's probably not many projects that you're not going to be able to compile. Yeah,
I mean, it was 14.8 million lines of code.
Oh, 40 more.
And now OpenCV, it's complex code, as I said, but it's a well-made library and has been written to be cross-platform, which means it should work with any toolchain. In the same way that if you had some code that worked with C++ on Mac OS, and then you tried to run it in Visual C++, you might run into things. You might run into things like that if you compile it with C++ Builder, if someone just hasn't written code that's intended to be compiled with any C++ compiler, that's been written for a specific one. The main thing that we try to say here is that if it's been written like the vast majority of open source have, runs on multiple compilers, shouldn't have to do anything special for us anymore. It should just work.
Yeah, you kind of de-specializing the code back into something standard, which is a great step forward. Debugging, I think you did actually mention this, but that's the other thing.
Sorry, Ian. Just before we go on to a debugging question, I didn't answer the question that Senator asked, which was about the COF format, meaning can we use a lib compiled with Visual C++? Look, we do not recommend that at all. Don't do it. The reason is that every C++ compiler has a different ABI, a different binary interface. Visual C++ uses a different standard library, has a different STL with a different implementation, and things are stored in different locations in memory and things like that. And if you try to link it to, that is a recipe for problems. If it's something simple like a DL import library, sure, or a plain old C kind of library. But anything C++, just recompile with C++ builder. Yeah. So Ian, thanks. Please go ahead.
Yeah, I mean it's not a deficiency in our compiler. It's just that it's a bad idea in general, because if you took any other C++ compiler, you would probably get the same problem because of the ABI incompatibility in the background. So, and if you're not sure what ABI compatibility is, then you really need to recompile it from scratch. Yeah, debugging is the next question by Simon Hooper. Are there improvements for debugging? For example, we were unable to set statements when debugging in 12.1. It was broken, blah, 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 blah. Is this fixed in 12.2? I'm not sure the specific problem he's talking about. But
I'm not sure about the specific problem either. I'm able to set a statement, perhaps like evaluate or modify a statement or something. Look, in general, we fixed a bunch of stuff in 12.2 and we'll just keep on doing it. If there's a particular bug that is in your way, I put my email on the screen, and actually, Ian, I wonder if you can screen share just the last slide, please.
Yeah, I can just do that. Hold on.
Thanks. And look, we obviously see the bugs that go into our bug system, but if there's something that is blocking you, email me. We'll definitely look into it. Other than that, I'm sorry I'm not familiar with that particular bug, but in general, we're fixing everything every release.
Just 1 second. I'm making my screen do what it's supposed to do. So here we go. Slideshow. Present your view from here.
Sure. Just while you do that, Ian, I'll answer the next question. So Roll asked, can C++ packages be used in Delphi some way or another? Yes, actually. So, yeah, packages are really interesting. Now, you can use Delphi code from C++ easily because the Delphi compiler emits a C++ header for the Delphi code. We don't go the other way around, so you can't directly get some kind of like Delphi interface generated for C++ code. What you can do though is that because a package is a package, you can load it with load package. We have our RTL method load package, and if you have types in there, you can use them. What we see people doing often is, and I've recommended this, there's actually a demo on our GitHub, to use C++ within Delphi. One technique that is really easy is to build a package. Then you define an interface or an abstract class or something like that in Delphi that has the kind of Delphi way you want to talk to whatever library it is that you're taking advantage of. Then in the C++ package, you implement that interface in C++. Use that to talk to all your C++ code. The Delphi app loads the package with load package and gets, calls a method, like give me an instance of this interface or something like that, gets an instance of it, continues talking to it as though it's written in Delphi because it doesn't know any different. So yeah, things like that can definitely be done.
Yeah, hopefully I'm sharing the right screen. The good news is that I can't accidentally share.
Oh, I actually can't see it.
Okay.
Oh, there we go. Yes, I can. And it's there.
Yeah, good.
Fantastic.
There's different views. As I said, go to webinar. That's why I don't like using it. I like Restream. I get Restream, and you can do all sorts of weird, crazy stuff with it. It's good. I mean, go to webinar is the original, big daddy of sharing. Okay, so BPL packages, can they, if we compile C++ BPL packages, can they now be used in Delphi in some way or another?
Oh, sorry, that was the one I just answered by
Oh,
role.
was it? Sorry, yeah. Too
So
busy staring at
yeah,
the screen. Click
yeah,
go green then, yeah.
generally
Okay.
compile one and then send back a Delphi interface to your Delphi code. Then Delphi can work with whatever you give it as though it's Delphi.
Yeah, okay. There was another one that I really wanted to pick up, which is try and compile you already covered. And
Yeah, try and compile is wonderful, and you can still use it. Yeah, we've tried to build something in by default, but it's also still really valuable for the other tool chains as well, and try it with the new one. But yeah, we're just trying sort of by default to have a bunch of performance out of the box.
yeah,
There's a
okay.
related question, Ian, which is asking about to use the new parallel compilation. Should the project options batch compilation be turned off? No. It actually uses batch compilation. That's how parallelizes, by sending a whole bunch of files at once and then doing as many as it can. There's a queue and it pulls them off and that kind of thing, and that is batch compilation.
Yeah, actually,
Leave that on, and then there's something called like a jobs setting. If you leave that set to 0, it will just use as many CPUs as you have, so saturate everything. So just basically leave the defaults in Win64 and it'll do it.
yeah, and actually there was a similar sort of question about a slightly different area, but it's related. Someone asked if it was possible to set the -W all, so the all warnings. I think you had a slide about, is it possible to set up as a default? And I think the answer, I think they were saying, like a project option, that per project you could turn it off and on. And I think that the answer there is you can. Is that right? Or I misunderstood?
Yeah, I would have to check, but I think you currently have to turn it on with the checkbox. There are two ways. Like there is a checkbox for turning on all warnings, or you can pass additional compiler flags with -W. Or like I think currently you have to do that per project.
Yeah, I know, because I'm more the Delphi guy, and I know with Delphi you can do that to a certain degree by doing the additional compiler flags if per project if you really wanted to. Personally, I have things turned on all the time so that I know when it's going horribly wrong, and I need to go and have a lie down. Bottom one here by Paul Jackson, Ashley's left, but it's a good question anyway. Ian, can you or David speak to the compatibility of the CB proj files between 11.3 and 12.2? Can they go back and forth? And I think I know the answer to this, but I'll let you answer.
We don't generally recommend that. I mean, we support upgrading project files. So when you open 11.3 using 12.2, it will go and upgrade and modify it slightly. Now you could look at what it modified and then try to use it, but it's completely unsupported, and we would not recommend that. If you really want to do that, just copy the project file, keep an 11.3 version, and then let 12.2 use its version.
And this is what GitHub is for as well, so you can restore individual things if you have to. GitHub is the ultimate get out of jail free card. Rainier says, where can they get the full set of demo files for the OpenCV/BTK handling using the Embarcadero toolchain?
Well, that's on our GitHub. Go to github.com/Embarcadero. We have a pinned item on the top called Rad Studio 12 Demos. In that is CPP folder. In that is CMake folder. Now to use that, and I should have mentioned this, you need to install our version of CMake. We have changes. We're going to send them back. But right now, just go to the Get a Package Manager and install CMake and install Ninja. I have a blog post on this, and I probably should have gone into more detail in the webinar. I didn't want to miss that. Like go over the same material again. But
I count 43 slides. That's quite in depth.
Yeah. Well, I mean, try to really want to cover as much as possible, really. But yeah, look, when you use the demo and you have our CMake and Ninja installed, there's a batch script for OpenCV. It's called make_OpenCV, I think, and just run it. Should work.
Cool. What was the other question? Oh, actually, I'll answer this question. It's kind of from for either of us, but I'll answer it, which is, I just accidentally hit scroll on this stupid go to webinar questions thing, which really needs to be big. They were asking about platforms, multiple platforms, and I'll answer this on behalf of the company, which is, people were saying things like, when will Android be added back in, when will iOS be available, and the rest of it. Look, they had to go for good reasons, and now you understand part of why that is, because the CLang, or the addition of Clang, was a significant amount of work. It was a big thinking of a direction with the C++ compiler toolchain, and not only that, it had such significant advantages like the amazing speed. And I know we're kind of go, oh, we're really excited about this, but this is genuine. This is not some sales pitch. We've not been told to hype this up. We're genuinely, really genuinely excited about the improvements in the speed, the quality, the compatibility. So many good things about moving to Clang that I don't want to say it was worth dropping the other platforms, because of course I understand some people it's been extremely painful, but we had to do this in order to move on. It comes to a point where, you know, you just have to say, I know this is going to be painful, but we have to move on, and that's what's happened. Now, lots of people are asking questions about different platforms. The number one platforms that we get asked for are Android and Linux. And Idera are very particular. People say, oh, give us a roadmap. And Idera, who are a company that own Embarcadero, are very specific about not giving out roadmaps. I've explained in blog posts before why they don't do that. They have some very complicated multi-territory laws and things like that they have to comply with. If you give a forward-looking statement, you can get yourself in trouble with all sorts of compliance agencies in legal bodies. So that, I know it sounds like they're being mean and not telling people what's coming up, but there are some reasons why they don't do it. Tell us what platforms are the most important to you, and give us some ammunition, give us some evidence that there are people out there saying, I really need Android, I really need Linux, I really need this platform, that platform. And that is helpful to us, the PMs, Devrel, myself, and others as well, because of course we want to give you what you want. That's the whole point about Embarcadero as a company, is we're not a black monolithic cube where stuff comes in and you never hear from us again. If you email us, we respond. We always, all of us, give out our email addresses, and we really do reply. And particularly me, if you email me, I will reply probably same day, and quite often within a few minutes, which is slightly terrifying to people, but I'm nice. But tell us what you want. If Android is a big deal for you, or Linux or whatever, or ARM, which is another one that comes up, tell us, and we will act on that. I make sure personally it goes in front of the right people, and so do the PMs as well. So the answer is, we haven't got an answer at the moment, but we're looking at it, particularly ARM, because we're even talking to Microsoft's ARM team about that, because we're having dialogue about what can and can't be done.
A couple of other questions they just answered in the chat.
Pick some that make sense.
Yeah, one of them was about in various open source folders there used to be ifdef all in C or similar constructs, and is that still relevant? Look, in general, no. It's most likely there as a workaround or a compiler specific thing, and we've had a bunch of times we've just gone and had to remove them, you know, because we're now so good that having workarounds can cause problems. So, and look, compile, and if it works, fine. But if it doesn't work and you see something like that, then yeah, absolutely, just go ahead and delete it and see what happens.
Okay.
If you do want a macro, then this slide I shared earlier with you know, code gear C and Clang major greater than or equal to 15. That's what to do.
Yeah, a couple of questions as well about patches and updates, and people saying they're having problems with patches and things like that. Some of them are to do with we had a compatibility issue between 12.1 12.2.0, 12.2.1 and 12.2.2, and going backwards and forwards between those versions. We have explained that and tried to say sometimes you can, if you happen to install 12.2.0, so the very first version of 12.2, and particularly something like TMS software components, if they were installed during that process, and that's TMS are one of the people that do that, they recompile all their components as part of the installation process. If you then installed the patch 0.1, you probably have an issue with that. It's saying that there's a missing entry point or something like that. Stephen says he's removed all those, still getting a problem. Stephen, if it's still an issue, raise a support ticket. If you go to the website and go to the support link, there's a contact us and then support and explain the problem. If not, you can also email me, ian.barker@embarcadero.com. That's how our emails work with our name. It could be a number of reasons why there's still a problem. Paul Jackson's still here, okay. Any other questions you want to particularly address, David, or?
Yeah, I'm just going through and I've had to scroll through a few. Let's see, there are a bunch that have just come in. It's very nice, many sort of thanks, which is really good. So I'm glad you guys appreciated the webinar. Thank you for passing that on. There's a question here, does Seabuilder 12.2 fully support all Clang 15 features, or do we do any kind of cherry picking? I think it should support everything that's in Clang 15 and libc++ 15. Double check by looking at our status page. Like if there was anything that needed particular tweaks for the C++ RTL or something, we should have that documented. What we support and what we don't. It was one of the URLs I put up earlier, and we'll make that available. But we do have documentation which C++ standards which items in each C++ standard we support. So yeah, check that. Question on Clang sanitizers, whether they'll be added. Yeah, would love to. Can't promise anything coming in the future because we can't do that in webinars, but it's very high on my priority list. That's all I can say.
They do have a special punishment for us if we say the wrong thing. That's why David's where he is and why I'm hiding in Dallas. Yeah. Yeah.
See, there's a question about a C++ 98 warning, compatibility warning. I'm not familiar with that one. I think I would double check the settings in your project to make sure if anything odd is being sent to the compiler there. Otherwise, drop us an email and we can look into it.
Yeah.
Let's see, a question about other C++ ABIs being compatible. Are there still vendor-specific differences? Yes, every toolchain is different and has a different ABI. Now, we are looking at whether in the next major version we could try an ABI match something. You can tell I'm being vague. It is unusual to be able to do that, and no one does. So, like, Visual C++ is different to MinGW, for example. So just assume, unless we get really excited and tell everyone, but just assume that it's different and incompatible, because that's how it is in the C++ world in general.
Yeah. Okay. I think we've covered most of them, to be honest. There's going to be some others.
Yeah, I think I can see something here about header dos.h. Look, that will be one that's left over from Turbo C, DOS. So we don't ship that anymore, but the particular methods you're looking for, get time and get date, and there are methods to get time and date. So that would be something where we would recommend using a newer newer C++ standard.
Yeah. I mean, I know it sounds like we're saying, hey, just upgrade, hey, come on, do it. But it's I mean, David and I mean, obviously we keep our jobs if the company stays, what's the word I'm looking for, financially sound. However, the reason we're saying to upgrade is actually because we really do think it's a major improvement. This is a sea change thing that hasn't happened for some years when it comes to C++. This is a big deal for David in particular, because this is his project, but also for me as well, because I want the company to succeed and go ahead. But I mean it. We're not just saying this because we're being prodded in the back by sales and marketing people, because that's really not what's happening. This is a big deal for us because we think this is something special, and just try it out and you'll see for yourself. If you're on an older version, download the trial. It won't cost you anything to download the trial. Prove us wrong. Download it and try it out for yourself, because we think it's that good that actually, if you try it out, you go, you know what? Yeah, it is. It's really fast. It's really compatible, and it's a major step forward. And you know, if you've got Visual Assist built in as well, it's an absolute you know, game changer when it comes to productivity and stuff like that as well. So it's a great thing.
Plus the other thing is, I mean, this is our version 1, and we are really recommending you upgrade to it. If you run into any issues, you know, email us, email me or support who are on the screen. You know, we want you to be successful here. You know, we know that with any new toolchain there are potentially issues, you know, because it's a different toolchain or because it's a new toolchain. And I tried to avoid promising that it was completely issue-free or that you wouldn't run into anything, and actually by talking about things that we know you might run into. But if you run into something, let us know. You know, we want you to be successful.
Yeah. I mean, that's the thing. I always say this to people, you know, the people with Embarcadero and in their email address really are a bunch of fanatics when it comes to products, which is a good thing. You know, the PM team, development team, DevRel, marketing, that I've never worked with such a bunch of people who really care about the product. And it's great fun to be involved with a bunch. Sometimes we get to meet up. We all met up in Portugal recently and hang out. And it's not like work most of the time. There are days when it's like work, but overall, you know, it's great to work with a bunch of people who really care about what this is and really are engaged with, you know, steps forward and things like that, and so on and so forth. Okay, well look, we can keep going for hours, and we'll be going for, is it 2 hours now? Yeah, I think so. No, hour and a half. Not bad. I've got a webinar starting on Friday that's an hour and 40 minutes, and I haven't even done anything. It's all pre-recorded. But is there anything you particularly want to address before we go? I think you've covered most of them.
I think we have, yeah. Look, again, it's quite possible we've missed something because we have hundreds of questions in the log. And again, I'll just emphasize, email us. You know, we're happy to talk if we don't answer here.
Yeah. Okay.
And yeah, look, basically we're excited and we think this is the future. So
yeah.
Give it a go. Contact us. Let us know how it works.
Excellent. Yeah. All right. Well, brilliant, David. Really good presentation, and you know, you're talking from the heart, and I really like that. This is how I prefer to do things. Is to, you know, I think if you get people who are genuinely engaged in what the idea is doing, you're definitely the guy for that. And myself as well. I love Delphi, and I have always used it. And so I know this is C++ webinar, but I think people always go, oh, your webinars are always so exciting. But why wouldn't I be happy? I've got the greatest job in the world. I work in every day with the language and an ID that I you know, used for many years in my development and stuff like that. So it's not difficult to be upbeat and happy when we think things are going well. So okay, all right. Well, thanks very much, everybody.
Because it has been a big project, but it's been really good because we really, you know, tried to solve everything and tried to do it right. And I guess when you do that kind of thing, you know, I've been contacting people like a company I used to work for who used CBuilder and told them, hey, you know, try this one. I think it's really worthwhile. And when you're at that stage, you know, that's a real recommendation. And so I do hope that shows through. You know as well as I do, it's a version 1, you know, but we reckon this is the one to go for. Try it.
You got to start somewhere, and this is a very good start.
Wonderful.
Yeah, you know, I mean, this is you and I have had private conversations where David bowls in, it's like super enthusiastic, like, oh my gosh, and then he shows the stuff. I'm like, actually, that really is good. You know, I think the open CV thing was a real light bulb moment for everybody because we knew this was a big difference. This is not like a little point release or something like that. I know technically it is, but it is a big step forward and a really good one as well. Giuseppe wants to know, can you have a T-shirt like him? No, you can't. these are kind of teamer only.
Oh,
I'm
sure
sorry
you
about
can.
that. You're kind of notionally on my team there, Giuseppe, but I'm afraid this is a DevRel only one. I'm the only guy that always wears the Embarcadero shirts all the time. The reason I do that is actually very specific. Just as an aside before we go, I want people to know that when you see that badge on my chest, you know I'm talking on behalf of the company. We don't have to put little disclaimers saying on YouTube saying this is a sponsored thing. I want you to know that if I say something, if I give you an answer, it's on behalf of the company, and we stand by what I say. Now, nobody comes back and slaps me around if I say the wrong thing, but the company do trust me to engage with you honestly and openly as much as we can within the realms of legal constraints. And so whenever you see me, if you see me at one of the events, you'll see me walking around in this shirt all the time. I want you to understand that I understand my position. I'm here on behalf of the company, representing the company, and that's what I do. But it's cool. All right. I think we'll call it a day for now, David. Are we good to go?
Yeah, I think so. So I was just replying to a bunch of people. But for all of you who I haven't replied to, and there are a lot of people, thank you for watching.
We'll
hope you found it informative.
Questions log as well anyway, as we always do, but just to make sure that we've got copies of those. The way that the chat log works is we do know the email addresses of people that have asked certain questions. If there's one that's particularly significant, and has not been answered elsewhere, then we'll try and address them as well, because it's important. Well, thanks very much, everybody. I'm going to end the webinar in a couple of seconds, but thanks to David, my colleague, senior PM, on your officially RAD Studio IDE and C++ builder. Is that right? I'm never quite sure what your responsibilities are. Just man.
Yeah, there are three of us, and we generally split things. So, for example, Marco is Delphi and I'm C++, and that's easy. We have Nunu, who looks after Visual Assist and Delphi Illustrivo, which are both C++ and Delphi and IDE, although I look after most of the IDE. It's a big product. We have to split it up between us. So you could roughly say IDE, C++, and debugger would be my areas, with a few caveats.
My role is official talker. That's my job. All right. Well, thanks very much, David. Thank you, everyone, for joining us, and we will catch you next time. There will be replays of this if you registered, and if you're on this call and you're definitely registered, you'll get an automatic email at some point in the next day or so with a replay link. We will also put this up on our YouTube channel, so that are replays, and we'll probably do a blog post summarizing this with a embedded YouTube video in there as well. So don't worry if you've joined us late or you missed something or you wanted to recap. You will get the replays. We always make sure of that, and we'll probably have links to the slides as well, I should think. Okay, well, thanks very much, everybody. See you soon. Bye-bye.
All right, thank you. Goodbye.